Hello, this is Mrs. Horton, 8th grade math teacher. I'm going to go through the lesson 1.06 model Pythagorean theorem. So this is the Pythagorean theorem right here. This represents a model. We're going to go into more depth with that. Really what you just need today is your math notebook and a pencil or pen to take some notes. Won't need a calculator today. All right, so Pythagorean theorem applies to only right triangles. So you need to make sure you understand what a right triangle is. It's the relationship between sides of right triangles that states that the sum of the square of the legs is equal to the square of the hypotenuse. And the hypotenuse is always C. And the legs are always A and B. So here, right here, is the right angle. So this is our right triangle. And the hypotenuse is always across from that right angle. And it's also the longest side. So this is the hypotenuse. And so that's always C, and the other two sides are our legs. So here's the theorem. This is on your formula chart or your star reference chart for 8th grade math. It states A squared plus B squared is equal to C squared. So you can see if this side length is 3, you square it, you get 9 squares. This side length is 4, you square that and you get 16. And when you add those together, you get 25. And if this side, the length is 5 and 5 squared is 25. So that's how it works. So today's focus is just on modeling that. So let's go ahead and make sure you understand right triangles. What do you already know about them? They all have a 90-degree angle. Here's this 90 degree. The hypotenuse is always across from that 90-degree angle. It's the longest side, and then the other two sides are the legs. So let's look at these right triangles and spot the hypotenuse. So we have on this first one here, look at our right angle, and we've got the hypotenuse. Let me get my pencil, and I'm going to put it in blue. Here's the hypotenuse right here. I'll just I'm not going to write them out each time, but that side is the hypotenuse. All right, the number 2, here's the right angle, so across from it, this side is the hypotenuse. Number 3, here's the right angle, go across, so here's the hypotenuse. So just always make sure you understand which side is the hypotenuse. Again, always the longest one and across from that right angle. So here's another picture, a way to look at it. So, and this was on my first screen. So we have A squared plus B squared is equal to the C squared. And put it all together with our formula. This number plus this number would equal the C squared. So this we actually already went over. So how does this work? And here's the numbers. Well, I talked about this on that first slide there, or the second slide. Here's the square for this one. This was 9. This was 16. This is 25. So it's 3 squared plus the 4 squared is equal to 5 squared. Let me just write that on the board just so you can see it in the formula. This side here, I'm going to put in blue, is 3, so you square that. This side here is 4, so we square that. And then this is our hypotenuse. I should use the colors they had. Whoops. Oh well, is 5, so that should be equal to 5 squared. And you can check that. This is 9. This is 16. And it does equal to 25. So that's how it works. So let's do we'll just do a couple of practice problems here. So this one, I believe, was an actual STAR question a few years ago. So it says, which statement is true? So we have square N, square L, and square K. So it says for A, the sum of the area of square N and square L, so sum means add, so you add this area plus this area, is equal to the area of square K. Now that's it. We already hit the correct answer. So look at the other ones and let's see what makes those wrong. So on B, the sum of the areas of square N and square L, look, says greater. So that's what makes that wrong. They are the same. It's equal. For C, the sum of the areas of square N and square K, nope, wrong one. So that's definitely not right either. And then D, the sum of the areas of square N and the square of, yep, again, wrong one there. So that one is incorrect. All right, let's do one more practice problem. This one. So it says, oh, I'm in the way now. Let me move myself. An artist joined 3 squared regions on their vertices to create the figure below or shown below. So this time we have X, Y, and Z. Now be careful, here's our right triangle or right angle. So this one is actually the hypotenuse. So let me label that. So that's important for you to make sure you understand which side is C. This one is C. Doesn't matter which one you put for A or B, but so remember it's A squared plus B squared is equal to C squared. So here's our question. The artist will use small congruent square tiles to cover each region without any gaps or overlaps. Based on this information, which statement is true? The number of tiles needed to cover the region in region X, so that's here, is the same as the number of tiles needed to cover both Y and Z. So you can see this is very small, and if we could put these together, it's definitely not the same. So that's not A. All right, for B, the number of tiles needed to cover region Y, this one, is the same as the number of tiles needed to cover both X and Z. Again, if you put these together, it's much larger than that one. So not B. C, the number of tiles needed to cover region Z is the same as the number of tiles needed to cover both X and Y. That one is true. All right, finishing up, y'all. So make sure you go in and complete your OMS lessons. Reach out to your teacher if you have questions.